Hello and welcome to the second video tutorial on WinBUGS. In this video we're going to go ahead and show a simple example of a model and solve the Bayesian estimation problem on it using WinBUGS. WinBUGS, by the way, does not sequentially read your code. It's a non-sequential compiler, so that the order of your code, just in case you didn't know, doesn't actually matter. The code itself comes in blocks or sections, and the first block is your model, and you specify it with keyword model and you enclose it with your curly brackets, and inside of it you introduce your prior distributions and your likelihood distributions. For example, here we have n, which is normally distributed at and these two parameters are the parameters for your normal distribution at mean 0 and precision 0.0001. Precision here is 1 over variance. For a list of all your distributions, you can go to user manual and distributions, and here you can access the syntax for many different distributions. Also, we have likelihood, which is normally distributed at a precision of 0.1. This likelihood corresponds to the data, the measurement that we have, which is 1. Here, you could technically just write, you could assign, and in the model block, assignment comes in an arrow form. Or if you have large sets of data, you could take advantage of what we call the list structure. And this is what your second block of code, for example, would contain a list of all your data. In this example, we only have 1. This third part, actually, we'll talk about it. For now, I'll delete it, but that's your initial condition. So what you can do now is go into model specification, and now you can do you have to do a series of checks syntactically and semantically before you actually solve the Bayesian estimation problem. You highlight your model block and you press check model. The bottom left is a good indication of the status of the check. If it's correct, it'll tell you, and if it's not, it gives you normally a good few words of what the error might be. Once the model is checked, you can load the data. In this case, I'm highlighting the list structure. I'm loading it, data loaded, and you compile. And now it has an option of either loading your initial condition or generating them. Now, what are these initial conditions? They are the initial conditions for the chain of MCMC, and if you load them, you're providing them yourself, and if you generate them, it simply pulls them from the pulls some value from the prior distribution. Now, if your prior distribution is vague or weak, where the precision is very, very low, the problem is that it might actually select a very, very high value or very low value with respect to the convergence point, which means that it may just take a very long time for you to converge. So alternatively, you can go ahead and provide it an intuitive estimate of what that initial condition should be, which in this case we do, and then you can load that. Now, once that's done, you go into the inference samples option. In this case, for MCMC, we have 1 node, and you can set this in order for you to be able to do different things in it during the MCMC process and after, in terms of analysis. There's a very cool feature called trace, and it allows you to see the samples in the MCMC. And in order to now solve the problem, the Bayesian estimation problem, you go into model, update, and you set a number of iterations you'd like. For example, I'll put 5,000 here, and your refresh rate, which just has to do with the display here. So in this case, I've done it, and you can watch the trace of your samples on Venn as it goes. And now, once that's done, you could do a series of really cool things with N. You could, for example, see the history, which is a big picture of your samples as you've iterated in MCMC. And this corresponds roughly to how convergence looks like. You could see your density your posterior density, and it is almost in a normal shape, which, by the way, convergence would fully require it to correspond to a normal distribution. And your stats, which are the statistics for the pulled samples, which are all derived from the actual samples in the MCMC here. And these are the statistics, for example, the median, the mean, the standard deviation, and the percentiles as I've set them here. And you see that it has some intuitive sense, this median, with the indications that we've set here for the n for the normal distribution. We've given it already a value of 1, and as you can see from the posterior distribution, the samples are around 1.033. And so this is generally what you do for the Bayesian estimation problem for this specific example and any example that you have. Thank you for watching.